Airborne hydrogen, upcoming carbon-free power source. Even though hydrogen is often hailed as the fuel of the future, one of its most challenging issues has been locating the water needed for electrolysis. It has always been challenging to produce hydrogen using traditional methods in places with scarce water supply. Researchers have made great progress in extracting water vapor from the environment and separating it into pure hydrogen and oxygen with a system called AirGen. Because it can manufacture hydrogen even in arid environments, this cutting-edge technology is revolutionizing energy production, remote locations, and even space missions. We'll look at the operation of AirGen, the importance of this development, and how it might affect global hydrogen production in the future. Is this the discovery that opens up hydrogen energy to everyone? There are currently two main methods for producing hydrogen, and both have drawbacks. The first is electrolysis, which separates hydrogen from oxygen but needs a lot of water and electricity. The second is steam methane reforming, or SMR, which produces carbon dioxide as a byproduct while extracting hydrogen from natural gas. SMR is therefore by no means the best clean energy source. The lack of water is one of the main barriers to hydrogen production. 1 kilogram of hydrogen requires 9 liters, or 2.4 gallons of water to create, and this does not even account for the additional water loss due to practical inefficiencies. This implies that traditional hydrogen production is not a viable substitute in dry regions, rural communities, or drought-prone places. AirGen resolves this problem and enables the production of hydrogen without a liquid water source by removing moisture directly from the air. This might significantly change how hydrogen is produced and distributed, making it more scalable and available in previously inaccessible parts of the world. The core concept of AirGen is simple yet powerful. Like a sponge, the device draws water vapor from the surrounding air using a moisture-absorbing substance. Similar to a conventional hydrogen generation method, electrolysis is used to divide the water molecules when sufficient moisture has been gathered. However, AirGen does not require liquid water to operate, in contrast to traditional electrolysis. Rather, it uses the humidity in the air to create its own water source. It is perfect for areas where conventional electrolysis is not feasible due to its ability to function in extremely dry circumstances. Experts predict that AirGen's efficiency, which is currently 15%, will soon reach 30% or more. AirGen would therefore be a commercially viable means of producing hydrogen, potentially competing with existing techniques while being more sustainable and scalable. AirGen is a groundbreaking invention since it enables the production of hydrogen in areas with scarce water supply. Though they lack the water resources required for electrolysis, many of the world's windiest and sunniest locations, such as deserts and remote islands, are ideal for generating renewable energy. Thanks to AirGen, these regions can now generate hydrogen, creating new opportunities for renewable energy consumption. This suggests that remote regions of the Sahara Desert, the Australian outback, and the United States could all produce hydrogen locally without importing water or fuel. One of the primary disadvantages of hydrogen has been its scalability, despite the fact that it has long been seen as a promising clean energy source. Hydrogen is often generated close to its consumption sites due to the high expense and difficulty of transporting it over long distances. AirGen changes this equation by making it possible to generate hydrogen anyplace without relying on a centralized water source. This might result in a decentralized hydrogen economy, where local production of hydrogen replaces long-distance transportation from industrial sites. Without traditional fuel infrastructure, AirGen might offer a steady and dependable energy source in isolated and off-grid areas. This is particularly advantageous for disaster relief efforts, military installations, and remote communities that require an independent power source. In the field of hydrogen transportation, where refueling infrastructure is still one of the biggest obstacles to adoption, AirGen may also be very important. Although there aren't enough hydrogen filling stations to support widespread use, hydrogen fuel cells are currently found in vehicles, trucks, and buses. AirGen would make it possible to build hydrogen refueling stations anywhere and do away with the need for liquid water sources. This would enable hydrogen-powered cars to be refueled in remote locations, making hydrogen a more practical and scalable mode of transportation. Another intriguing possibility is the potential application of AirGen in spaceflight. Future missions to Mars face a significant challenge in locating sustainable energy sources due to the absence of liquid water on the planet. However, Mars' atmosphere contains water vapor, which might allow a device such as AirGen to directly gather hydrogen and oxygen from the Martian environment. This might create rocket fuel, oxygen for humans, and energy for shelters, creating a self-sustaining ecosystem for future space expeditions. Although it is still merely a theoretical application, the capacity to produce hydrogen fuel without liquid water could be a big step toward long-term space flight and human settlement of other planets. Even though the AirGen system is just in the prototype stage, researchers are already working to scale it up and improve its efficiency. Portable AirGen hydrogen generators for homes and businesses, integration with wind and solar farms, and extensive commercial hydrogen production utilizing air-derived water are all possible within the next 5 to 10 years. Businesses and governments are already showing interest in investing in this cutting-edge technology, which has the potential to make AirGen a significant force in the hydrogen economy in the near future. If efficiency levels can be raised to 30% or higher, AirGen might become one of the most widely used hydrogen generating methods worldwide. The groundbreaking technology known as AirGen may be able to address one of the primary problems with hydrogen, which is its need for water. By removing water vapor from the environment, it enables the production of hydrogen anywhere, including in deserts and disaster regions. Because of its improved efficiency and mass production, this technology has the potential to have a big impact on the future of clean energy, transportation, and perhaps even space travel. One of the biggest developments in the history of renewable energy may be the ability to create hydrogen without the need for liquid water. As a result, hydrogen would become a future fuel source with virtually endless potential.